Alright guys, welcome back. We're going to be looking at the triangle proportionality theorem today. So I'm not here in class today, but yet I'm here with you. So let's talk about what that triangle proportionality theorem is. Follow along in your notes if you would. It says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So when we look at a conditional statement, it's going to look like this. If DE is parallel to AC, then BD is proportional to DA, and BE is proportional to EC. That's what that states. If DE is parallel to AC, then BD is proportional to DA, and BE is proportional to EC. I can also look at the converse of that triangle proportionality theorem and say that if BD is proportional to DA and BE is proportional to EC, then DE is parallel to AC. Okay, so that's what that theorem states. Let's take a look and do, we'll do numbers 1 and 3 together. So if I look here, we have we have parallel lines intersecting. So now I can say that 12 over 14 is proportional to 15 over x. And again, we've already, figured out how to do these. So I can say 12x equals, I'm going to cheat and say it's 210, and divide both sides by 12, and I get that x is equal to 17.5. Okay? And of course you can go ahead and plug back in your answer and make certain that you have the right answer. Okay, on number 3, I'm going to say that x over 36 is equal to, if this whole length is 55, this length here is 10. So it's going to be equal to 10 over 45. So now I have 45x equals 360. Divide both sides by 45. And I'm going to get that x is equal to 8. Okay? So that's how that triangle proportionality theorem looks. Now, there's also another theorem. Oh, hey, it worked. All right, there's also another theorem that we're going to look at. And that's the proportional parts in parallel lines. So it's similar to the triangle, but here, obviously, it's not a triangle. But it still creates proportional parts. So this one says if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. So what that means is I know that AB is parallel to CD, which is parallel to EF. So those are my 3 lines parallel to each other. Then I can say that AC is proportional to CE and BD is proportional to DF. So it's very, very similar to that last theorem that we looked at. So over here on number 10, I'm going to say 45 over 18 equals 52 over x. I'm going to cross multiply and I get 45x equals, cheating once again, 936. Divide both sides by 45, and x then is going to equal 20.8. And of course you can go and plug that back in and check to make sure your work is correct. But that's what you're learning today. If you have questions, write them down and ask me, or ask each other. You can figure it out. All right. See ya.